All right, this is the review for our first interim test. It's over everything we've done so far this unit. So let's jump in. Freebody diagram above shows the forces acting on the box being pushed to the right. Describe the motion of the box. Okay, so for the first thing that we're going to look at, we're going to interpret the Freebody diagram. What we see from all this is that the left and the right force are equal. The up force and the down force are the same as well. So what we see is that all forces here are balanced. And so the net force on this object is 0. So when the net force is 0, that's a big important phrase. When the net force is 0, we can say the acceleration is 0, and if that's the case, the object will move with constant velocity. A skateboard rolls along a rough concrete surface and comes to a stop. All right, so if it's coming to a stop, a net force causes the skateboard to accelerate opposite its velocity. That's what stopping means. And so what's going on is we have friction acts opposite the velocity to slow the object down. If we look at the skateboard, we have its weight, we have the normal force, and then the force of friction would be backwards and the velocity would be this way. This is going to be the skateboard slowing down to a stop because of that. And just as a note, we have no forward force it will keep moving forward on its own without any extra force. There's not going to be any forward force to make that happen. All right, describe the motion of an object that has positive velocity and negative acceleration. Anytime the velocity and the acceleration are in opposite directions, the object will slow down. That's how that works. That's an important thing. Anytime you have positive velocity and negative acceleration, the object will slow down. And it's the same free body diagram that we had. We got normal force up. We've got the weight down. We've got friction backwards. This object, and then velocity is going to be in this direction. It's moving forward. But again, velocity is not a force, so that object will slow down and stop. The net force is opposite the velocity. The object's going to slow down and stop. All right, 4, we have free body diagram for our situation above. That's a car. It's moving to the left. So if it's initially moving to the left, my velocity is going to be to the left. What force acts on the car to make the vector to the right increase so much? Describe the motion of this car. So for one thing, the velocity is that way. The net force is to the right, so the acceleration is to the right. So net force is to the right, acceleration is to the right. So this car is going to slow down. The acceleration is opposite the velocity, so the car slows down. Chances are we're still driving forward, but we've got the brakes on, where there's a lot of friction. Okay. Draw two free body diagrams that represent an object that's moving with constant velocity. If it's moving with constant velocity, these are our objects. One of them could have balanced forces this way. And if force 1 is equal to force 2, those things cancel out. For the other one, if we have force 1 up and force 2 down, as long as force 1 is equal to force 2, those things cancel out and the object will move with constant velocity. All right, so for the bug and your windshield, yes. Your windshield exerts the same force on the bug as the bug exerts on the windshield. That's Newton's third law. That's an equal and opposite force pair. Your windshield doesn't shatter because it has less acceleration and then the little formula thing that I want you to keep in mind, the forces are equal, but the mass of your car is much bigger, so the acceleration of your car is smaller, and the mass of the bug is smaller, so its acceleration is much bigger. The difference in mass means that there's going to be a difference in acceleration. All right, what causes something to accelerate? A net force or an unbalanced force. Those are the same thing. Causes acceleration. Describe the net force of an object that's moving at a constant rate. At a constant velocity, net force is equal to 0, acceleration is equal to 0. We have to keep those things in mind. All right, next unit. This is the one that we just did. What's the difference between a revolution and a rotation? Revolution is moving in a circle around an object. This would be like a ball on a string. And then a rotation would be moving around an axis. This would be like a spinning top. What are the formulas for circular motion? One of them is that centripetal acceleration is v squared over r. This is how we calculate centripetal acceleration. And we have to remember that for centripetal acceleration, that's toward the center, and that's something we get anytime we move in a circle. So that's anytime an object moves in a circle. The other one is that velocity in a circle is equal to the circumference of that circle divided by the time it takes to go around a circle once. That's the period, or the time for one revolution, and that's the circumference. So it's still distance over time, it's just our specific distance once around a circle, the circumference, divided by the time it takes to go once around a circle, the period. An object travels in a circular path of 2.5 meters at a speed of 12 meters per second. Calculate the acceleration of the object. All right, well, we're going in a circle, so we have centripetal acceleration. Anytime we see circular path, we've got that. It's going to be v squared over r. The velocity is 12 meters per second. The radius is 2.5 meters, so we have 12 meters per second, whole thing squared, over 2.5 meters. And we end up with a centripetal acceleration of 57.6 meters per second squared. What is centripetal force? This is the force causing an object to move in a circle. One thing to keep in mind is that this points to the center of the circle, and this could be any number of forces. Could be the normal force, it could be gravity, it could be friction, it could be tension. Any number of forces, could be just some applied force. Any number of forces could cause the centripetal force, but it has to be caused by a real force. A ball is attached to a string and a student is swinging it in a circle. What's the direction, force, acceleration, and velocity of the ball? What happens if the string breaks? Force and acceleration are centripetal because we're moving in a circle, and that means they point to the center. Velocity, well, the speed will be tangential. That points along the radius. If the string breaks, we will continue in that tangential path. So whatever direction that tangential velocity is, that's the way that we're going to go. The relationship between period and frequency is inverse. Namely, 1 over the period is equal to the frequency, and 1 over the frequency is equal to the period. That's the relationship. Because frequency is the number of revs per unit time or per second, and the period is number of seconds per revolution. All right, what's the velocity of a ball with a mass of 2 kilograms? So that's our mass on a string that's being swung in a circle. The centripetal force is 20, and the length of the string is 2 meters. So that's our length, and for how this works, that's also our radius. So we have mass, it's 2 kilograms. We have force, it's 20 newtons, and we have radius, That's 2 meters. So I know that if I want velocity with those things, I know that velocity and radius together, centripetal acceleration is velocity squared over radius, but with this, I need the acceleration, but I've got force and mass, and so force, mass, and acceleration together, well, I've got net force equals mass times acceleration, and so if I've got 20 newtons equals a mass of 2 kilograms times the centripetal acceleration, I can solve for the centripetal acceleration, divide by 2 kilograms, divide by 2 kilograms. And so I can get the acceleration to be 10 meters per second squared. So I can plug that into here, and that gives me 10 is equal to speed squared over the radius of 2 meters. So that tells me, so multiply both sides by 2. And that tells me 20 is equal to v squared. Just square root both sides. And so that tells me that v is equal to 4.47 meters per second. All right, moving on. The constant motion on a highway. A car is driven 40 kilometers during 2 hours of travel, 60 kilometers during the next 25 kilometers. What's the average speed for the entire trip? So average speed is going to be the distance traveled over the time. So to get the distance traveled, we're going to take 40 kilometers and add 60 kilometers and add 25 kilometers, right? So we're going to add all of our distances together. That's 125 kilometers. And we're going to divide that by the time it takes for the whole thing. So for the time, we've got 2 hours, 0.3 hours, and 0.5 hours. Well, that's 2.8 hours. So we put all that together and divide. That gives me an average speed of 44.6 meters per second. All right, here's a relative velocity question. Car A is traveling to the north at 60 miles an hour. It's passed by car B, which is traveling to the north at 90. What would a passenger in B measure for the velocity of car A? So here's car A going at 60 miles per hour. And then here's car B going at 90 miles per hour. So what we want to know is, from the perspective of car B, what does it look like car A is doing? Well, car B is going 30 miles per hour faster. So it's pulling away from car A at 30. So car A looks like it's going backwards. So it's going to the south. That's backwards in this case. At 30 miles per hour. That's how fast car A is going to look like it's going. All right. So if Jane walks 12 meters north, make sure we do this right. So we have 12 meters north and then 30 meters west. We want to know what's the magnitude of the displacement. Displacement is distance from start to finish. So for us, our displacement would be that straight line from where we started to where we ended. That's the hypotenuse of the triangle. So displacement squared is going to be 30 squared plus 12 squared, or the displacement is the square root of 30 squared plus 12 squared. That makes the displacement 32.3 meters. If you have things that go together like a triangle, you can't just add them. You have to do the Pythagorean theorem. What's the difference between distance and displacement? Distance is your total distance traveled. So think of it as an every step. For displacement, that's just the distance from start to finish. What's the difference between speed and velocity? There's a couple of differences. So for speed, that is how fast with no direction. Speed is also distance traveled over time. It's a different calculation than velocity. We'll do it this way. Velocity is how fast plus direction. And to calculate velocity, we have to do displacement over time. So a bear runs for 2 hours, so my time is 2 hours, at 10 miles an hour, so my speed is 10 miles per hour. And I want to know how far, that's x. Well, I know that velocity is displacement, distance over time. So with my numbers, I got 10 is x over 2, multiply both sides by 2, and that tells me that 20 meters is equal to the distance, 20 miles is equal to the distance that the bear goes. Draw two graphs that show an object that has an acceleration of 0, positive acceleration, and negative acceleration. Distance over time and velocity over time. 6 graphs total. Okay, so we're going to do position versus time and velocity versus time. We're going to put them all together on the same graph. So position versus time, velocity versus time. So we'll do in red one that one that has 0 acceleration. Acceleration is slope of velocity. So 0 acceleration is 0 slope. So if we were to draw that, that is equal to 0 slope, or acceleration equals 0. And then over here, acceleration is the curve. Acceleration equals 0 is no curve. So if I have positive velocity here, I'm just going to have positive slope for position. Now, negative acceleration, we'll do that one in green. Negative acceleration is going to be negative slope. We have negative acceleration. Well, that's just going to be, we'll do that. So negative acceleration here is going to be a frowny face, or downward curvature. And this one we're moving backwards, so negative acceleration is going to look like that. Positive acceleration is positive slope. So an upward slope is positive slope. That's positive acceleration. And then positive acceleration over here is some kind of happy face. Because I have positive velocity the whole time we're moving forward, it's going to look like that. A man walks forward at 4 meters per second on a bus moving forward at 30 meters per second. What's his velocity relative to an observer on a sidewalk? So if that's the bus and it's going 30 meters per second, an observer sees that as 30 meters per second. But if there's somebody on top of the bus going 4 on top of the bus, the observer sees those two things added together. So what they see is this person walking forward with a speed of 34 meters per second. All right, draw a distance versus time graph that shows a position with, let's see here. So we have position versus time. They start off with a position of 2 meters. The person moves at a constant velocity, and it takes them 3 seconds, so 1, 2, 3, to reach a position of -1 meter. At that point, they stop for 4 seconds to smell a rose, so 1, 2, 3, 4, which means they don't move anywhere. They stay at -1 meter. I'm going to extend that. And then they move to a position of 8 meters at a constant velocity, and then stop after 4 seconds. So we'll go 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8. So they're going to end up way over here, and they're going to stop and talk to their friend. All right, so we have a position versus time graph here. We want to know the acceleration of the object from 15 seconds to 40 seconds. All right, because that's a position versus time graph and that's a straight line, it's a straight line on position versus time, so it has a constant velocity. Constant velocity means the acceleration is 0. Now, if I wanted to find that velocity, it would be the slope. So the change in position, we go from 60 to -40. So -100 divided by the time, 5, 10, 15, 20, 25, over 25. That velocity would be -4 meters per second. We get that by finding the slope. All right, projectiles. A bullet is fired from the top of the cliff. How high is the cliff if the bullet is on the ground in 6 seconds? All right, well, so this is a y direction question. So in the y direction, the acceleration is 10 meters per second squared down. Because it's gravity, it's always 10 meters per second squared down. The initial velocity in the y direction is 0 because it's shot horizontally from the top of the cliff. The time it takes to hit the ground is 6 seconds. And what I want to know is the delta y. So we need to pick an equation that has all 4 of those things in it. Delta y is v0t plus 1/2 at squared. That goes away because it's 0, and so delta y is equal to 1/2 times 10 times 6 squared. So our delta y comes out to be 180 meters tall. How far will the bullet travel if it's shot with a horizontal velocity of 1,200 meters per second? Well, that's in the x direction. In the x direction, the acceleration is 0. The velocity in the x direction is 1,200 meters per second. And the time is 6 seconds. And I want the delta x. Well, in the x direction, same equation. Delta x is equal to v0t plus 1/2 at squared. The acceleration is 0, so delta x comes out to be 1,200 times a time of 6 seconds. So delta x comes out to be 7,200 meters. What's the magnitude and direction of the acceleration due to gravity? Just as a reminder, magnitude just means size. Direction is direction. So for the acceleration due to gravity, g is 10 meters per second squared down towards the center of the earth every single time. Draw the path taken by a projectile. Well, if we shoot it up like that, it's going to be a parabola. If we fire it off of a cliff horizontally, it's going to be a parabola in that direction. Okay, cannon is fired from the top of the cliff. What would change if the horizontal velocity of the cannonball was multiplied by 4? Time would be the same. Time depends on the height of the cliff only. So if you want to think of it that way, in the y direction we would determine time. The initial velocity in the y is 0. The acceleration is 10 meters per second squared down. And then our delta y is the height of the cliff. Time depends on all those things. Delta y is v0t plus 1/2 at squared. But none of those things, none of that has to do with the velocity that we have to begin with. That's an x direction question. The acceleration, the x is 0. The initial velocity is v, right? The time is whatever the time is, and it's not changing. And delta x is velocity times time. So if I multiply the velocity by 4, I have to multiply the delta x by 4. So we go 4 times as far if we increase the horizontal velocity by 4. What would increasing the height of the cliff by 2 change? This would change the time of the fall, because from here, with the initial velocity of 0, delta y is 1/2 at squared. And if we solve that for time, it's the square root of 2 delta y over a. So if we increase it by 2, time gets bigger by 1.4 times. And because the time is longer, it would increase the distance as well. Write a definition for each of Newton's laws and give a real-world example of each. First law. Objects will stay at rest or move in a straight line with constant speed if the net force is equal to 0. This is inertia, or the idea that mass is stubborn. The second law tells me that the acceleration of an object is the net force over the mass. More force I get, more acceleration I get. More mass I get, less acceleration I get. The third law tells me that forces occur in equal and opposite pairs between objects. And you can go back in your notes and look up examples of each of those.